All right, guys, Chapter 3, Part 1. We're talking about something called independence today. So we'll just read through this paragraph to understand it a little better. In sports, athletes are sometimes described as in the zone, hot, or even on fire when they are able to string together a series of successes in their sport. It could be a goalkeeper saving many shots in a row, or a basketball player nailing several three-pointers in rapid succession. You might be used to this with like guys like Steph Curry, players like that they catch fire. And this is kind of a phenomenon that we're going to be exploring here. So to keep reading, coaches may even try to identify which players are hot and scheme to give these players extra opportunities to score for the team. To explain this phenomenon in the scope of statistics, we must define two conflicting principles: independence, where things are not as related one after the other, versus dependence, which we'll talk about as the hot hand, and also streakiness in sports. Because the hot hand is more of a positive thing, but it can go the other way as well. You can have a cold streak where things go bad in rapid succession. So we'll go over both of those examples here. So we'll fill in some blanks here first. An athlete's attempts are defined as independent. And pardon my handwriting, I'm not very good at using these things yet, but it's all good. So an athlete's attempts are defined as independent if his or her ability to succeed is not influenced by previous success or failure. Okay, an athlete's attempts are defined as dependent. Dependent if his or her ability to succeed is influenced by previous success or failure. This is also called streakiness. You can put some quotes around that as well. Okay, like if an athlete is streaky, it can kind of go both ways, all right? So, the hot hand is an example of statistical dependence. We'll put that down first. The hot hand is an example of statistical dependence, meaning that an athlete is more likely to continue making shots each time he or she makes another shot. Now, on the other hand, a cold streak, that's our next fill in the blank, a cold streak is also an example of statistical dependence, meaning that an athlete is more likely to continue missing shots each time he or she has missed another shot. Okay, last fill in the blank here for the top part. If there is no statistical proof of streakiness, then we must assume that an athlete's attempts were independent. Okay, so this is with no statistical proof. I think if I zoom in here, maybe the handwriting will look a little bit better. So no statistical proof. That's basically our null hypothesis is always going to be that an athlete's attempts were independent. Yeah, that's better. Whoops, what's going on here? Let's try that again. Struggle is real, guys. Here we go. Independent. There we go. Okay, if an athlete's attempts are independent, that means that any streaks that we see are due to random chance. So we'll write that in as well. So in this chapter, we're always thinking of independence as that's like our null hypothesis, right? We just chalk it up to random chance. If we do prove that there is some kind of streakiness, whether it's a hot hand like up here versus a cold streak right here, then those are examples of dependence, but that's really what we need to prove statistically. So for each scenario below, we're going to just go through some of these and talk about whether it's the hot hand, independence, or a cold streak, okay? In 18 holes of golf, so this is number 6, in 18 holes of golf, a player lands 16 of her drives perfectly on the fairway. She has a streak of 12 holes in a row with perfect drives. Okay, give you a second to think about what it might be. And the answer is the hot hand, right? This is a positive streak. It's a good streak. This is what every athlete would love to have. It is the hot hand. Okay, if only you could play like that all the time, right? Okay, moving on to the next example. Playing 10 games of roulette at the casino, the ball lands on red twice, then on black twice, then on red 3 times, then it alternates black, red, black. Obviously, there's no streakiness really happening there. So take a second again to think about whether this is independence, the hot hand, or a cold streak. Also with these kind of games at like a casino, they really wouldn't want players to necessarily go on streaks because then they're more likely to lose money to those players. So this is actually a really good example of independence. Yeah, a lot of those casino games are predicated on the idea of every event is independent and they are likely to win over the people playing at the casino every time. Okay, number 8, in the 2014 Men's World Cup, goalkeeper Tim Howard of the United States set a World Cup record with 16 saves against Belgium. Okay, and again, this is like a good streak. He was playing really well, and he was able to just do that over and over in a row. So this is another example of the hot hand. And I'm not really writing on the lines. Sorry, guys. Number 9. In a college football game, of course, it's BYU. This probably didn't really happen, but we just put this example in here. The BYU quarterback completed only 3 out of 15 passes, including a streak of 8 incomplete passes in a row. We should know by now that incomplete passes are not a good thing for a quarterback. So this would be an example of a cold streak. This is a cold streak. All right. Number 10, in an NBA game, LeBron James makes about half of his overall shot attempts and scores 20 points. Now, we're not really given evidence either way. Like, it could be that maybe he made half of his shots, like he made those all in a row, and then he missed a bunch of shots all in a row. And because there's really not a lot of evidence or anything going on here, this would be a good example where we just have to uphold the idea that each shot was independent. So our fill in the blank, our answer for number 10 is independence. All right, on to the next page. I'll flip the page over and give you guys the audio noise of flipping the page. All right, guys, on to number 3, chapter 3, part 1. What am I talking about? Number 3. We're just moving on. We're moving on to the next page. Our description of dependence. Okay, so to explain how the hot hand and cold streaks both describe dependence, let's analyze the record of a particular high school basketball team, the Dunford High School Dragons. The Dragons had an exactly even 50% winning percentage, but there's a catch. Each time they won a game, they were 60% more likely to win the next one. This would indicate that they had the hot hand. Oh, I just had a bug right on the desk. Sorry, guys. Okay, there we go. This would indicate that the team had the hot hand as long as we have enough statistical evidence to prove it. So down below, complete the following definitions and the table below to further explore the relationship of streakiness. So, like the paragraph said, following a win, the Dragons were 60% more likely to win after a previous win. Okay, now that means that the likelihood of them losing after a win is going to decrease, right? So this is kind of redundant, but basically we're saying that if they win, then they're less likely to lose the next game, obviously, because they're more likely to win the next game. This part can be a little confusing, so stick with me here. This relationship describes the 2 possible outcomes following a win, or in other words, sometimes we just call it like a success, right? Because it's not always about wins and losses. Sometimes it's about makes and misses, things like that, okay? Now, the next part, following a loss. What goes up must come down, and streakiness behaves the same way following a loss. In other words, if the Dragons lose, then their winning percentage drops to 40% in the next game. These guys are a bunch of head cases, I guess. This means that they were 60% more likely to continue losing after a loss. This relationship describes 2 possible outcomes following a loss or a failure. That's kind of an intense word here. But, statistical successes, statistical failures, that's what we're talking about. So next part. Now we're going to fill out a table below using percentages to kind of describe that relationship in just a straightforward numerical way. So the overall average is what I would put in first. And what we were told overall is that they win 50% and they lose 50%. So we'll write those numbers in, okay? But in addition to that, we want to remember that every time they won a game, their winning percentage increased, right? So we can put this here, 60%. All right, and then I'm actually going to go over to the loss category, okay? So every time they lost a game, they were more likely to continue losing. So we're looking at basically this category and this category, okay? And that's where we're going to put a 60% as well, right? So these 2 scenarios that we filled in, these 60s, represent that streakiness, okay? The 40% we're going to put in here is just the alternative option, right? So if they previously won a game, they were 60% more likely to win, which means they were 40% more likely to lose. Okay, and the same is true for the other side. If they previously lost a game, then their likelihood of winning the next game drops to 40%. Okay, now let's talk about how this relates to our hypothesis testing. I'll leave that there for a second. Maybe I'm going a little fast here. I'm recording this on Thursday. What is it? October 2nd. So still haven't had the baby yet, but going to be coming here in the next 72 hours. Let's keep going. So really in the next 48 hours, but either way. Hypothesis testing the connection. By the time you guys are reading this or watching this video, hopefully the baby will be here. So that'll be great. Okay, let's get back to the notes. I'm just rambling. It's just like class. Hypothesis testing connection. There's our 15-minute bell. Okay, now that we have a new concept to study, let's tie it in with what we already know by filling out an updated version of the p-value table. Our new bits of knowledge tell us that streakiness must be related to change in ability, and independence is related to random chance. Okay, so the left side really isn't going to change here at all. Okay, the left side here, if we've got a small p-value, that means we're going to reject the null hypothesis, accept the alternative hypothesis, okay? Now, if we have a large p-value, or a p-value that is not small, right, a p-value greater than or equal to 5%, then what that means is we are going to have to uphold the null hypothesis and reject the alternative. We just don't have enough evidence yet. Okay, now let's put the reasons, and this is where it's going to relate into our idea of streakiness, okay? So if we have let's go down, now we'll do the top part first, okay? So if we do have a small p-value, right, we go through like a whole statistical test, and we haven't really done this yet, so this is just kind of setting up an example later on. If we do get a small p-value, then what that means is that it is unlikely that the streak we're analyzing could have occurred by random chance. We'll start with that. It is unlikely that the streak could have happened by random chance. Okay, and with that, all right, if it's unlikely that it could have happened by random chance because the p-value is so small, this is our proof that an athlete's ability must have increased or decreased based on the previous outcomes. Okay, we're kind of tying it in with the definitions from the very beginning. All right, so again, small p-value, it is unlikely that the streak could have happened by random chance, comma. So the athlete's ability must have, wonder how far off the page I can go here, must have increased or decreased based on previous outcomes. Increased, yep, it'll let me go right off the page. Or decreased based on previous outcomes. Okay, this is just a very fancy way of saying that if you have like a, say Steph Curry makes 6 3-pointers in a row out of like a certain number of total shot attempts. We'll go through the process in a second of how we do our hypothesis test. But if we go through that scenario and we get a low p-value, then we're basically just saying, yeah, it's unlikely that could have happened for Steph Curry by random chance. His ability probably increased every time he made a shot, and he was catching fire, and he was having one of those classic Steph Curry moments. So let's go to the next scenario, right? So the next scenario is a large p-value, or a p-value that is not small, greater than or equal to 0.05. In this scenario, it is likely that a streak could have occurred by random chance, so we must uphold the idea that the outcomes were independent, okay? So we'll write that down here. It is likely that the streak could have occurred by random chance. It is likely that the streak could have occurred by random chance. So the outcomes are independent. Independent. Okay. Just means there's really no connection here, right? Like, say a different player just shoots, maybe he makes like 3 3-pointers in a row, and then he misses a couple, and then he makes a few more in a row. And if you were to go through a random chance simulation, go through like the whole hypothesis testing process, it would be likely that could have just been something that happened by random chance based on how good the player was. Okay. So there we go. We've got these that we'll refer back to later on. But now let's go down and we'll do a full example. We're looking at the 2008 Green Bay Packers. I think this was early career Aaron Rodgers, if I remember right. So let's get into it. In 2008, the Packers had 6 wins and 10 losses. They started out the season strong with 4 wins, 3 losses, but their season was doomed after a streak of 5 losses in the second half of the season. Is this streak of losses enough evidence to conclude that the Packers were a streaky team, or was it possibly just due to random chance? So first thing we want to do here is decide what is the longest streak. And that's there's a few ways we're going to analyze streakiness. And the first one is just by looking for what is the longest streak. Okay, so we've got a streak of 2 right here. That's not very long. We got a streak of 3, right? So 2 wins, 3 losses, then a couple losses, a win. And then right here, this is the longest streak, right? We've got a streak of 5 losses in a row. Pretty rough way to end the regular season. They did have a win right at the end, but 5 in a row to give them, 5 losses in 6 games to end the season. So let's explain the null hypothesis in the context of independence. And it's going to be like this. Each game was independent. Okay, this is the null hypothesis. Each game was independent. We'll start there. And any streaks or possibly, I think there's 2 S's in possibly, isn't there? Let's try that again. Or possibly, wow, what a mess. It's fine. Possibly due to random chance. Okay, and it's a lot more likely that you're going to have some kind of random chance streakiness in teams that have like either a lot of wins or a lot of losses. Okay, a team that's close to 500, any streakiness that happens for a team like that, maybe there's something going on there, right? But in this scenario, yeah, this is just, we're basically saying that, yeah, for a team that's 6 and 10, having 5 losses in a row, maybe that's just possible that could happen by random chance. Okay, and now we go to the alternative hypothesis, and this is what we're interested in testing. So based on the success of the team, are we trying to prove the hot hand or a cold streak? Take a second to think about it. Remember, the hot hand would be for a team that's really good. A cold streak would be for a team that's really bad. So we want to think back up to these numbers here, right? 6 wins, 10 losses. And that's kind of a rough season for an NFL team. So I think that the idea here, and we can just kind of circle this is going to be an example of a cold streak, okay? Let's try circling that again. There we go. It's a little better. Oh, we accidentally erased it. One more time. Classic old guy move. Okay, here we go. So it's a streak of losses, and that's the main thing that we're kind of pointing out here is that it's a streak of losses. That's why it's a cold streak. Streak of losses. Okay. And really, like, dude, if you think about it, we'll just pause for a second on this thought. Before they hit that streak of losses, like if we were to just look at the first part of the season from here to here, they were what? 1, 2, 3, 4, 5 wins and 1, 2, 3, 4, 5 losses, right? So they're 5 and 5, and that was like not bad. Like you got a chance to make the playoffs, and then they just hit 5 losses in a row, and that just kind of ruined the season. So let's decide the alternative hypothesis. State the alternative. Yeah, no, we already read through that. And there's a little stupid grammar thing here I keep meaning to fix, but oh well, right here. We can just cross that off. All right, so our alternative hypothesis would be this. The Packers' ability to lose games, okay, because it's a cold streak, their ability to lose games increased each time they lost a game. There's actually more than one way to write this out, so we'll write both, but we'll start with that. Okay, the Packers' ability to lose games increased each time they lost a game. Okay, the other way we could write it is we could say that their ability to win games decreased when they lost, right? So we're just thinking about it in both ways. If they're more likely to lose following a loss, that also means that they were, whoops, let's redo that. I don't know why that happened. Okay, that also means that they were more likely. Wait, sorry, we're repeating what I just said. Try again, guys. My bad. Kind of messing up this part. They were less likely. Sorry, they were less likely to win a game following a loss. I feel like we just butchered that part of the lesson. Guys, this is the first video I'm making, so if it's a little rough, I'm sorry. Stats, you guys only got to bear through one of these videos. Okay, so now, as a class, we're going to use, well, we're not going to do, it says we'll simulate the possible streaks that could happen by random chance. Where do our in-class simulations land on the dot plot? We're skipping that part here, okay? It would kind of involve laying out note cards like what we've done before and just counting the number of streaks that could possibly happen by random chance. Because I'm not here to do it, that's fine. All we're going to really do here now is we got to think about what is our test statistic, okay? So our test statistic, okay, and this is really like part E here, all right? Based on real life, we go back up here. It was this five losses in a row. Okay, so we put that in, 5 losses in a row. Find this number on the dot plot and count the number of dots that are at or above this point. Okay, so this is what happened in real life. And guys, at this point, the hypothesis testing process doesn't change at all. We just have a new test statistic. So what we do is we find that, just like we've done previously. We put a mark. We say this is what happened in real life. Okay, and now because of that, we're basically going to go through and we're going to count up the number of dots that are there or higher. Okay, the real life value or higher. So take a minute to do this. I'm going to give you a second, maybe like 10, 15 seconds. Just count up the number of dots that are on all of the, basically in the box we just made. Okay, so we talked about how when there's this many dots, it's not really super important that we're perfect, okay? The number of dots, the correct number is 41, all right? But if you were to count like 40 or 39 or 42 or 43, it's not going to matter much. And the reason why is because it's still going to give us a large p-value. So we go down to part E and we continue on. Okay, 41 out of 100, okay? And let's say this is the p-value. I'm getting a little ahead of myself here. We got an announcement coming on.
Thank you.
All right. Okay, so p-value, 41 out of 100, that gives us 0.41. That's the p-value, okay? So whenever we get this p-value, our next thought is, all right, well, is it small or is it large? And in this case, it's very small, or sorry, it's very large, okay? So 0.41 is greater than, this is kind of funny because on my paper that I'm kind of copying off of, I accidentally wrote less than 0.05, but it's definitely not. Okay, we think about this as like 41%. The cutoff point is 0.05. Oh my gosh. 0.05 or 5%. Okay, and 41% is much bigger than 5%, so it is large. It is large. All right, and what that means is that we are going to uphold the null hypothesis, H naught, and we are going to reject the alternative hypothesis, HA. All right, so the 5-game losing streak was probably just due to random chance. And who knows, guys, like we talked about those random chance factors, maybe it was something to do with a lot of road games in a row, or maybe their quarterback got hurt, maybe the defense was like having injuries or something. There's a lot of those reasons that, you know, maybe the team's ability didn't actually, like they weren't like a streaky team, but there were just things that went wrong. So this is really our conclusion, and we want to give a little summary, say something like the 5-game losing streak wow, still getting used to this. Okay, the 5-game losing streak was possibly, we can't rule it out, right? It was possibly just due to random chance. All right. And that is it for Chapter 3, Part 1. Thank you for coming to class today. If you were here, guys, thank you for bearing with me as we struggled through our first video. It's all good. Okay, briefly, guys, I'm just going to kind of go back through the notes. We'll just kind of zoom out and go a page at a time. And we'll just leave this up here for a couple of minutes, maybe not a couple of minutes, but like 30 seconds or so. And just sort of slowly go through. If there's anything in the notes that you missed, it would be a good time to get it copied down. And wow, what perfect timing. That was the bell going off right now to end class. I don't have no idea if you guys can hear that or not, but I'm hearing it. So here's our examples. And like I said, I'll be back next week, last week of the quarter, and we will be going through the next parts of the notes together. So if there's anything that doesn't make sense or is a little bit confusing, just let me know and we can answer any questions you got. The main thing to keep in mind here, guys, is that all we're really doing that's different from what we did in previous chapters is we're just looking at streakiness, which in this scenario, like the example we did, it was just the longest streak, right? It was this 5. Okay, it was this number right over here. Talking about this 5 right here. And there's going to be other methods of calculating streakiness that we'll learn later on. Once you have that number, that's your test statistic. Okay, the hypothesis process is the same. The p-value process is always the same. And I don't know why I'm just drawing on here by accident. And yeah, that's pretty much all, guys. So thanks for coming to class today, and we'll see you next week.